Hi everyone, thanks for joining us. Today, just like some note for your information, we're going to record the session so that later we can check it as well. Yeah, and 3, 2, 1, I think we can start. So once again, hi everyone, thanks for joining us today. And today we are starting the series. I hope it will be for a long time in terms of perspective of running these kind of events, not for sure only related to architecture, but other technology related talks. But we will start from the architecture. So let me start with an agenda for today. So actually not from agenda, with an introduction. So who am I? My name is Izzet and I'm working for EPAM as solution architect. I'm also a proud father of 3 sons. My primary focus in EPAM is Java and cloud related technology stacks. I'm also passionate about clean code and architecture. And in my spare time, I'm doing detailing of my car. Regarding agenda for today. So today will be kind of a hard topic, but I will try to talk about it in relatively simple terms. And I would like to do it in kind of a workshop format or as much as possible in an interactive way. For that, I will share with you some link a bit later and expect from you some interaction or collaboration with me. So we will talk about architecture first, then we will cover some topics related who is an architect, especially the modern one, who is an architect nowadays. And we will also touch a bit of information regarding the how to grow as an architect. If there are questions, I think you can answer them in the chat. Not sure whether I will be able to take a look at them throughout our presentation, but for sure, you will have a chance to ask those questions at the end of the presentation. So if everything is okay, I think we can start. So what is an architecture? This is actually the question to the audience. Let me oops, no, not this one, this one. Let me share the link with you in the chat. Wow. Okay, so please follow this link and try to answer the question. What is an architecture from your perspective? What does it mean to you? We will see answers in the screen, for example. If I follow this link, right, and type like architecture is about structure and of software, and I click submit, then we will see it here, my answer. So please, everyone who has some opinion regarding architecture, type what is an architecture from your perspective, what is an architecture for yourself. Okay, good, we have some answers except my one. So let's start from the first one. The thing that is hard to change after was built. That's right. Especially when something was released. However, like usually, of course, it depends on type of the software, right? If you're talking about some software as a service, things are changeable over time, but for sure, it's really hard to change after it was already built. Then we have another opinion. This is like, it's a decision about the structure of a product and all related systems and components. Good one. Okay, no comments on this. Architecture is a set of rules to build a system. Good. Probably you mean the author of this statement meant about the kind of patterns, something like that, that I agree with. Okay, set of patterns and technology, yeah, quite similar. Identifying software components and helping build them. Good. Set of principles that describe how to design components of systems to reach required goals. Good one. Components that work together to solve the problem. Personality is responsible to decision about which and how many components, element of design will be implemented and how they interact. This is a high-level view on the components and flows used for a specific solution, the overall design of a structure. Well, we've got lots of good answers, so let's just recap. So I would like to just summarize, but maybe some points were missing in your answers, and you will get them here. So architecture usually consists of. So I won't give you a definition of architecture because it's quite a wide term, but we will talk about like decent points or key points related to architecture. So architecture consists of elements and relations among them. I believe we had them in terms of components and so on from our answers. Architectural elements have attributes, or properties, right? So each element on the architecture has some attributes, some responsibilities, some like meaning to that element. Elements interact with each other via interfaces, like for sure, like when we're talking about architecture components, right, and some relationship between those components. Those components are interacting with each other via, for sure, some interfaces or API. Architecture suppresses element internal details and concerns with interfaces. So that's about the thing. Like usually when we talk about architecture, we can when we talk about architecture visualization, usually we cannot do this in the single diagram, right? And that's why there is a term view. View is representing some kind of perspective when we look at the architecture. And depending on the view, right, which is visualizing our architecture, some elements could be suppressed or hidden because they bring too much details and they're not interested in that view. So that's why we're talking here about hiding of some elements, details, which are not relevant or not quite important at this point in time for this kind of view. So an architecture design is based on a variety of requirements. So there were a mention of rules, requirements as well. So I think we covered that quite good. Okay, another slide. Let's talk a bit more regarding architecture. So could you maybe mention, or again, like type, maybe you can, actually you can unmute yourself. Let's say, what are elements on this diagram? Just maybe one or two examples and we'll proceed next. Who wants to speak?
Infrastructure.
Infrastructure is kind of whole thing of the architecture, right? Might be, but what are elements here? Maybe some concrete elements of infrastructure you can mention.
Some hardware, some hardware or subsystems which solve something.
Okay, yeah. So for example, Route 53, right, is an element according to your suggestion, right? Or S3 bucket, load balance, right?
So it's cloud diagram, right?
Mm-hmm. Yeah.
So yeah,
this is kind of a deployment view. Yeah, and we're talking about elements. What kind of elements we can see, we can name?
Some services provided by some.
Oh, good. Okay, good. So let's talk about element attributes. For example, we mentioned some services, right, or infrastructure elements. For example, Route 53 or this web server or load balancer. What are like those attributes those elements attributes?
Network-related components?
Network-related components, could you please clarify a bit?
If you want to, like in general, name it somehow, yes, so it's networking layer of the architecture.
Okay.
Or what was the question?
What are element attributes? For example, we mentioned web server, right? Or root 53 or S3 buckets. So what are attributes of those elements?
Maybe it could be, let's say, amount of requests which some servers can proceed in a minute, let's say, the percent of successful responses and so on. So how many data can be stored, the speed of processing maybe.
Okay, good. Other opinions? Three to one. Okay.
Yeah, probably actually talking. Talking about cloud-based infrastructure and cloud elements that can be tier level. This can be service class that basically actually defines the performance and the other limitations or restrictions or capabilities of the service.
Okay. Yeah. Good. So good. Let's move on. So my next question is: what are interfaces, based on your opinion? Could you mention like some interfaces that we can see here?
So it is surfaces which you communicate with. So defined surface which you can use. For instance, in this case, elastic load balancing. So you just, the interface there is to set up how many pods or instances you want, and it will scale. So,
yeah, but like I bet you're talking about user interface, or maybe I'm wrong.
No. I mean,
no.
I mean the interface that you, as software, you communicate, like software balancing. You mean that you have interface,
how you can
API
define...
interface. Yeah, for instance, it might be API interface in terms of load balancing. In terms of S3, it is
so how to configure
S3
API for configuration, right?
Not only, but also communicating between components, communicate via interfaces like through the S3.
I think it's some kind of abstraction, for example, so we can change. We not depend on RDS. We can change to another database, and we don't have to change any other services.
Okay.
So they depend on interface.
Yeah, actually, like this is a bit kind of tricky diagram, right? Because here we can talk about different layers, let's say, talking about interfaces. Agree with you regarding like using some interface, for example, of a Hibernate GPA, right, to work with database. And at the same time, we can talk about some lower level, like potential interface, which is like TCP protocol, or like HTTPS protocol, over which we can communicate between components. Okay, good. So let's move on. So let's talk about what element details are important here. What is suppressed or hidden, or maybe doesn't relevant here. Any ideas?
Yeah. So for sure, it is the whole software is hidden here. So we don't see the API surface of our software, for instance.
Yeah.
We don't have any. We don't have suppressed S3 detailment. I mean, we don't see the buckets list and so on. So any structure here. And actually, on the every level, kind of all the details are hidden, even on CDN network and kind of route S3, we don't see domain list and so on. So every layer here is suppressed.
Yeah, that's right. Okay, good. So actually, I'm quite impressed with interactions that we had. You were quite active in to type your answers regarding what is an architecture, and lots of discussion and interaction we have here. Okay, let's move on. Time is running and we need to cover some more additional points. So what does influence in architecture? This is my next question. And let me, yeah, I believe link shouldn't be changed. Yeah, so you can again like type here, yeah, you can type here your answers. So what does influence on architecture, based on which architecture is kind of needs to be changed, based on what inputs and so on and so forth. So from your point of view, what is important to architecture, what impacts it has, and what influence? Okay, we have first answer, www. So if I interpret it as like going from thick client, which is like desktop software, to the client server kind of thin clients, which is kind of internet based. Yeah, so this is like dramatic shift in architecture. Business requirements and available resource infrastructure. Good answer. For sure, like everything which is built from software perspective is just to fulfill some business requirement, business needs, right? And we need to consider for sure some infrastructure and other things. Okay, requirements for solution or application. Good. Restrictions, non-functional requirements. Wow. Yeah, actually quite good 2 points. Restrictions or constraints, as we usually name them, and non-functional requirements. Sometimes this is misleading, and we are also talking about quality attributes as a like analog of non-functional requirements. Okay, good. Architecture attributes like security, performance, scalability. Yeah, this is related to non-functional requirements or quality attributes. Good. Requirements, the current state of cloud service abilities, architect experience. Well, quite useful insights here. Yeah, so basically, based on the current state of cloud service abilities, so basically here I believe like we're also talking about some recent trends, right, which are happening in software industry in IT, with movement to the cloud, to like improvements which brings us cloud, and improvements which are happening to the cloud and so on. Architect experience, for sure, this is quite important point, because like talking about experience, right? I usually talk that there is no bad experience. Every experience is positive, whether it happened due to some failure or due to some success, it's still experience which will for sure impact your next architectural decisions as an architect. And we also have so-called term like architecture influence cycle, right? When you have some experience, you design something, then based on your design, you get some feedback, and then in next architecture, the new experience which you get from that like previous cycle will impact your next decisions and next architecture. Good. Business decision, political security. Yeah, I agree. Scalability, durability, availability, price of used services. Okay, quite good answers. Let's move on. So let's recap. So basically, to summarize everything that we were talking about, right, except there is no mention of the architect experience, but here we're talking about kind of main things, right, which are needs from our clients for the business, and those are three main things: functional requirements, right? So basically, these are all the business needs that we need to incorporate into new solution, to build new solution with respect to those functional requirements. For sure, there is no kind of any solution or application which cannot only like fulfill just like functional requirements, because there are some hidden expectations, or maybe sometimes not hidden. It depends on the maturity from technical perspective of your client, of your business, how this solution should work, and how the question can be answered with quality attributes or non-functional requirements. So basically, most of the architectural decisions that were made are driven by the quality attributes in order to make sure that there is a meet of expectations of how application solution will work. And constraints, right? Constraints usually something which is related to kind of zero tolerant made decisions. For example, we need to use some particular database, for example, Oracle, right, or MySQL, or we need to use only cloud, or vice versa, only on-premise installations. And this means there is a constraint which we cannot tolerate, right? We need to follow it. Usually, like, there is zero tolerance in the constraints. For sure, like talking about usual like functional requirements, right? Just from the experience on some of my projects at the like pre-sale phase, there were more than 100 pages of requirements to build software solution. Others, all requirements like equally relevant to the new solution? For sure, no, right? So only some subset of functional requirements are important to us, right? And that's why we have one term, which is ASR, or which stands for architecture significant requirements. So basically, this is a subset of requirements from functional requirements, from quality attribute or non-functional requirements and constraints, which are quite important from business perspective, from technical perspective, which as an architects, we need to focus on, right? For sure, like we cannot, if we name, for example, just quality attributes like security, availability, performance, scalability, usability, testability, deployability, and there are many entities, right? And we cannot fulfill all of them equally because it will be a nightmare from the architecture perspective, and it will be a nightmare from the development perspective, and it will be a nightmare in terms of costs of this solution, right? And one of the primary responsibilities of an architect is to distill the important parts from all the inputs that we get from business, from functional, from quality attributes, and from constraints, and to focus on them during the solution design and during the implementation. Okay, let's move on. So to recap, I have a couple of questions. Let's also try to bring some interactivity here. So here we have a requirement. System should support TLS 1.2 protocol for secure data transfer. Is it an architecture significant requirement or it is not? What's your opinion? Let's vote. Okay, it is an ASR. First answer. Any other opinions? Any more?
How to vote?
You need to, you need to select an option here.
Thanks.
Okay, we have more answers. Let's skip 1 or 2 minutes more in order to have more kind of statistics representative statistics here. Yeah, we have 7 answers. So no, okay, it's not an ISR, it's now first place. Okay, any other questions or any other answers? Sorry. It is an ISR. Okay, it is not an ISR. This is the leading answer. Okay, 5, 4, 3, 2, 1. Okay. Good. So I think we can fix the answers, right? So system should support TLS 1.2 protocol for secure data transfer. I'm like agree with you. It's not an ISR, right? Because basically we can like at the high level, right? We can differentiate, or we can identify whether it's an ISR or not based on the changes or impact on architecture. When we're talking about architecture significant requirement, right? Usually it meets client needs, not too expensive, easy to extend. Yeah, good one. I like it. Which we can easily modify, add new parts. Okay, this is quite related to the previous opinion. Yeah, I agree. Easy modify, it's one of the like quality attributes that might be important for some of solutions. Okay, good. Includes and considers all elements and interfaces involved in the solution. I'm not sure whether it is related to our question, right? Because architecture consists of elements and interfaces, right? But here some probably details needs to be explained. Okay, let's move to the next one. Those which covers ISR and allows scalability. Okay, that scalability might be part of ISRs, right? How easy to add new features? Time to development is linear. Okay, includes and considers all elements and interfaces involved in the solution. Okay, good. Lots of answers. You are good listeners and quite interactive guys, which means the product and custom requirements at the low expense. Okay, good. Good architecture is approach of developing where we can change or scalable system components independently. Okay, good. Documented, changeable, maintainable. Well, actually, here is quite important thing regarding documentation. Yeah, especially it's important when we need to like when we need to have evolution of our architecture. Saves customer money. Okay, quite good answers. Let's recap. So talking about what is good architecture, actually the easy answer, or maybe again like contradictory answer, there is no good or bad architecture. What does it mean? Like usually when we talk about architecture, right, each and every architecture is created to support or to fulfill some particular needs from the client, from the business, whatever, right? And basically, good architecture means that the one which fulfills expectations from the clients or from the business, what it needs to do, and expectation in terms of how it needs to like perform those duties that are expected from that solution. That means that like if no matter what technology stack, what set of patterns, cloud, no cloud, anything else, whatever, right? If architecture fulfills customer needs, expectations on how this like new solution, which was built, designed, right? Designed and then built, is like fulfilling everything, no questions, that is good architecture. If we employ lots of nice and shiny patterns, microservices architecture, or event-driven, bring to the cloud, everything else, and there is no fulfillment of customer needs, right? That is bad architecture, because there is no sense in all those shiny things we are as like technologists, as engineers, as developers, as architects brought to that solution. If it's not fulfilling the business needs, it's a bad architecture. That's pretty simple. I try to visualize this. Basically, on the left-hand side, we have kind of good architecture. Basically, we have ISRs, right? And we have architecture which kind of aligns with an ISRs. So basically, there are two like form some beautiful figure, let's say like this. And on the right-hand side, we have kind of ISRs and slightly not meeting everything architecture, right? So there is some gap. And that gap, the size of that gap is the level of, let's say, how this architecture is bad, because it meets or it fulfills some architecture significant requirements that were expected from the new solution, but in most of the cases it doesn't meet, right? And that means that architecture is not good because it doesn't fulfill the expectations that it should fulfill. That's why it is a bad architecture. For sure, like there are some details needed, but at the high level, at the brief like explanation, that are key things, right? Every good architecture needs to fulfill customer needs, business needs, to fulfill expectation on how application needs to behave. And bad architecture when there is no match. There's no match in this. Okay. Let's talk about next logical thing, which is like how to assess an architecture, right? Basically, we just were talking about what is good and bad architecture, right? But how to like make sure that architecture can be assessed. And I believe there is, yeah. So what do you think? How to assess an architecture? Any opinions? Code audit. Okay, good answer. Kind of agree, right? Because usually bad code quality means some bad things. Not sure regarding architecture, but yeah, some problems for sure. Compare the architecture against the SaaS. Good one. Actually, I spoke a bit the answer, right? Price, deployment, time of development. Okay, thank you. Any other opinions? Any ideas how to assess an architecture? Please do not hesitate to answer. It's easy. Document ISRs, document current architecture, assess. Good. Yeah, basically, actually there is like, there is a method which is developed by the Software Engineering Institute, which is EPAM, basically architecture trade-off in analysis method, which can be used in order to perform the assessment of architecture without even like creation of an architecture, basically by trade-offs which were made and so on. Okay, any other answers, any other opinions? Easy to follow by all stakeholders. Okay. Okay, 5, 4, 3, 2, 1. Okay, good. So we've got pretty good answers. However, like I spoiled a bit the answer, right? So on the previous slides, right, we have this picture. So basically, ISRs on the one side and architecture on the other side, right? If there is no alignment in those two like parts, it means architecture is not good. And basically by assessing how architecture is fulfilling ISRs, right? What design patterns we employed or applied in order to support, for example, performance, right? Did we introduce cache? Did we introduce some like caching layers even for some cases, right? Did we introduce some redundancy in order to kind of have some load balancing to reduce the load on particular instances of our application and so on? So all those different things we can apply in order to address particular quality attribute like performance, or maybe security or scalability or anything else, right? And then by assessing how good particular architecture significant requirement supported by our architecture, right? We can assess whether architecture is okay for this particular case or no. So pretty simple. Okay, let's move on. Let's talk about who is an architect. I believe most of you probably already an architect because of your answers, and that's pretty good. And you're quite interactive ones, so that's also good. So let's talk about who is an architect. I would like to talk here a bit long, right? This is because of the different terms that we are going to talk about. But from my perspective, this is quite important, right? One of the key things here, right, is statement at the top of the slide, right? Most of what architects have traditionally done should be done by developers, by tools, or not at all. What does it mean, right? So I believe, like, even from my experience, right, maybe like 10 years ago, there were no kind of the position of architect was not something which was often on every project, right? But nowadays we have more and more positions on the projects where we need an architect. Like there is some change happening, right? And in modern solutions, right, in modern software that we are designing and then implement, there are some changes, and the changes we can like to sum up it as like changing in the role of an architect. So usually, like, where if you talk about, like, say 10 years ago, architect might was responsible for doing like code review of each and every change that was introduced by developers, right? And to approve actually merge or like commit to the repository of our software, to define what or which programming language needs to be used, what library needs to be used. Nowadays, it is less important for architect to make a decision, right? That or that software needs to be used, or library for particular project. Why? Because there is like shift towards next thing, which is called architect elevator, where architect plays much more important and visible role. Even sometimes it's still like necessary for architect to perform code review, right? In order to be hands-on, to understand what is happening, what we are like committing, any maybe some like issues, code bugs, like to perform sometimes this audit, or to select particular maybe key technologies. That's still okay, but most of responsibilities of modern architect are shifted slightly, and that the description of this shift is actually can be metaphored as architect elevator. An architect elevator, this is metaphor, like if we imagine some organization as a building, right, which consists of floors, starting from the first floor or zero floor, where we have some engineers or like engine bay, right, where we have developers who actually write some code. And talking about like next floors on top of this zero floor, we have, let's say, quality engineers, we have some users, some support guys, and so on and so forth, up to the highest floor, like where we have management. And basically, this is our organization, right? Just imagine like building with the floors, which represents our organization. And architect elevator means that modern architects should navigate between those floors. So basically, to have some idea what is happening at the bottom floor, where we have engineers to understand the trends, to understand what is going on, how things are developed, or to navigate to the top to understand what is company strategy, what is important right now for the business, what will be important like in 3 or 5 years for the business, what like IT changes we need to introduce to the organization in order to have it successful, right? And to transfer those ideas to the lower floors, down to the engine, down to the like engine bay, right, where we have developers, and to make sure that that ideas that were shared with an architect on top are transferred to the engine layer or engine floor in order to develop or to implement those ideas to support through the software of the strategies that company has. And talking about architectural elevator, right, we can see here some like statements. Those are particular activities that architect needs to perform by navigating between those floors of organization. So first statement is runtime architecture considerations. So the statement is about importance of our solutions behavior in runtime, right? For example, again, availability, security, performance, those are runtime things, right, which are important to architecture. Those are like quality attributes of our solutions that we need to consider at build time during design implementation in order to fulfill expectations of how like performance should application be, or how secure it should be, right? Again, like a set of quality attributes are important for one industry, and another industry has another set of quality attributes which might differ from the first one in terms of importance. For example, for banks, right, security is quite important, but for example, for some account system, security is less important, right? But maybe performance is more important for it, and so on and so forth. So that statement is regarding the runtime considerations that architect needs to think about when there is a design of new solution. Automate software manufacturing. So as it was stated in the statement above, so nowadays, like we have lots of different tools, starting from continuous integration, continuous delivery, some Sonar Cube, PMD, find bugs, other stuff, which helps us to, all those tools that help us to reduce time each and every developer spend on some things in order to keep the quality of our software. And the more and more like different things needs to be automated in order to spend less time on that, because tools can do this faster, more frequently, with more quality, which releases lots of time to developers to think about code which will implement particular features, or an architect, for example, not to perform code review, right? But to think about how, like what design tactics needs to be applied in order to address a particular quality attribute, and so on and so forth. Next thing is minimize upfront decisions making. So that's quite an important thing, right? Usually, like, you know, like usually when we start some projects, right, usually we start with architecture, and this is like every time it is wrong. Why? Right? Because at the beginning of the project, usually this is the phase when we have less information about what it needs to do, how it needs to do it, and what are the expectations. And within Agile and Scrum and other like Agile software development methodologies, there is like frequent expectation that some requirements will be changed, business will change. That's why it's really hard to make upfront decisions. And one of the architect responsibilities is to allow software to be designed in that way that it will allow this minimum decisions upfront to support new changes, to support changing of decisions, and so on. Basically, the right time to make the hardest decisions, or like the strong one, which cannot be changed at the end of the project, when it's too late to make decisions, like from the business perspective, right? Because everything is about to finish, but that time is when good and right decisions could be made. That's why there is like a trade-off, right? We need to introduce, or we need to enable our architecture to evolve during the project life cycle or development life cycle, and to minimize upfront decisions. Okay, next point is cell architecture options, right? So basically this is related to like simplification of navigation of architects between different floors, right? Because at each floor there are people who speak different languages. QA people speak different languages than developers. Support people speak another language, and business people speak completely other language. An architect, by navigating between those floors, right, needs to adapt, or needs to be kind of a translator between, for example, business floor and the developer floor, or business floor and the support floor, and so on and so forth. And basically to sell architectural options. For example, we need to make this decision because it will impact that and that in this way for business, right? Or similar thing, but slightly different, using different words for support guys and so on. So basically, architect is a person who can speak different languages and to adapt his or her language to the people who this person is talking to, and to support ideas of architecture changes or decisions and so on and so forth. Okay, next point, make architecture fit for purpose. Actually, this point we already talked a bit more on that, right? Actually, like many times I was mentioning that every architecture is built for some particular business needs, or to fit some purpose, right? And usually, like again, like it's also related to good or bad architecture, right? As I said, there is no good or bad. It's more about fit, right? Whether architecture fits or is aligned with expectations from the business or from the client, what it needs to do and how it needs to do this. Okay, let's move on. Validate decisions through the feedback loops. So basically, I believe you heard about term like ivory architects or ivory tower architects. So in the modern world, it's completely wrong to have long feedback loop, and it makes sense for any basically industry profession and so on, because time is running and it's running faster and faster with like every time. And the same like happens to the architecture, right? We cannot only rely on solution or decisions by one person, right? We need to get feedback, and we need to have this feedback loop as short as possible in order to make a decision, validate it. If it's wrong, okay, let's change. If it's okay, let's keep it when it or until it makes sense. If something like was changed, business requirement or business like direction or some circumstances, and we need to adapt, let's not to hesitate to change the decision, because new decision will better support, will better fit the purpose of the software that we are building. That's why it makes sense to like keep this feedback loop and to not to rely on like particular person decisions. And to gather this feedback loop is also quite important from different floors, right? From QAs, from support guys, from business guys, from developers, so from everywhere. Okay, next point is architect the organization alongside technology evolution, because again, like this is also quite important because technology is changing. The pace of technology change is like increasing and increasing every day. For example, only like let's talk about, for example, Docker, right? Which was quite a hype in 2013. Nowadays, it's hard to imagine kind of modern software to be deployed not to Kubernetes, right? Which is the thing after the Docker, let's say in this way, and microservices and so on. So again, like several years ago, it was a hype. Now it's just a reality, and we are shifting towards different implication, application, or extension of previously good ideas to have even better ideas. How data software, how the software can be built in the modern world, and that's why like it makes sense to it's not make sense. It's necessary to develop to organization along with technology evolution, right? Because we need to bring new skills, we need to develop new skills into our teams, and usually architects are persons who kind of admitted to be knowledgeable about trends, and that's why architects need to contribute to organization development to keep organization at the pace of the technology evolution. Another point is remove blockers at the right floor. So usually, like different people speak differently, things differently, and so on, and there might be some misunderstanding or miscommunication happening, and some blockers or roadblocks appeared towards some particular decisions, right? And one of the key responsibilities of a modern architect is to, again, like navigate through the floors and to remove those blockers, to explain why we need that or that solution, why it is important, what it brings us, what will like trade off, and so on, in order to accept decisions, in order to move forward, in order to remove blockers. ArcOps, and this is another point, build a vertical architecture team. So again, like it's quite dependent on the level or the size of your organization, right? How many floors you have, right? How many levels, and how many people there are, and so on. What is the structure of organization? And like for some small startup, right, it makes sense maybe for one architect to do everything to successfully navigate between the floors and to remove those blockers and to basically to successfully communicate and across those floors. But in the big organizations, when there are many departments, decision makers, basically people, for one architect, it will be hard to do those duties. That's why it makes sense to build kind of so-called vertical architecture team, which will consist of different architect focuses. For example, at the lowest floors, we might have some technical leads or software architects or technical architects, right, which will be closer to the developers, who will understand like more about what developer speaks about, right? And then a bit up, we'll have, for example, solution architects who talk more about business and alignment with IT. And maybe a bit up, we will have enterprise architects, strategy architects, and so on. So basically, that team of architects with different focus across the vertical will help to like transfer or convert decisions between the floors, to carry information between floors, and like with the final goal to make organization successfully utilize IT solutions for the sake of business success. Okay, and the last but not least, keep riding the elevator. So it like with more and more changes, with new like lines of business or with change of the business attitude, conditions, and so on, there are like new ideas, new requirements are coming, some changes, and so on and so forth. And like architects needs to keep riding the elevator in order to understand what is the current business strategy, what are the recent business decisions that were made, what we are leading to as an organization, and what we need to introduce at the IT level, right, in order to support business strategy. That's why it's quite important for architect to navigate. Okay, maybe there are some questions. Let's answer them briefly if there are. If no, let's move on. So at the moment, no questions. Okay.
One more question. How important the domain knowledge is related to business domain? I mean, for the architect.
It's quite important, actually. Yeah, because again, this is like it's hard to like architect from, let's say, e-commerce or retail business domain to make some decisions in the healthcare domain, because you understand like those are completely different business domains. And in order to work successfully in the healthcare, e-commerce architect needs to be like dive deep into the business domain which he or her has less experience with. And actually, this is one of the like additional quite important attributes of an architect to be business acumen, which means like to fast, easy, or at least fast to grab any new knowledge which is required to work effectively with a new business domain or with a new technology trend or something like that. Okay, any other questions? Please do not hesitate to ask verbally, or you can type. Actually, we kind of run out of time, but if you need, you can leave, but I would like to finish just like a few more slides left. How to grow as an architect. That is one more topic. So basically, I would like to cover here some like educational activities or educational programs that we have in EPAM in order to grow for architects. Actually, like we are consider ourselves as like continuously learning organization, and like with an encouragement to learn something new by everyone at any level. And there are different educational programs for different roles, different levels within EPAM. And here is like brief overview of what we have in terms of educational programs for an architect in EPAM. So we have some open or public events, for example, architectural katas or technology events like this one, which are having right now. So by joining these events, you can learn something new, especially with architectural katas, with aim to actually practice architectural duties, to make trade-offs, to have decisions, to choose technologies and so on. Usually on the projects, it's like, it's a rare case when you can apply something without like negative considerations or negative consequences of that. But on architectural katas, we can do this without any issues. And there are a set of private programs related to, again, like to develop architecture. So we have Solution Architecture School, which is focused on future architects. For example, if you're a lead developer and you consider yourself as a future architect, you can apply for this program in order to understand like fundamentals of the solution architecture, who is an architect, some like architecture theory and so on will be taught here, right? And then you will have some like systematization of your knowledge, and you will identify your gaps in order to understand how you can grow next to the solution architect position. We have also Technology Solutions University. The focus group of that program is to allow architects to grow further. For example, if you're an architect and you would like to grow to like obtain new skills or to gain some like human dynamic skills, you can apply to these universities. There are different tracks with focus on different technology, whether it's like certification in, let's say, cloud, or it is like focus on enterprise architecture and so on. So everything is there. There is also a continuously running technology mentoring program. So basically with the goal to tune some particular narrow skills. For example, I would like to be more proficient with public speaking. I can find a mentor for myself, right, to practice with preparation of presentations, to conduct some talks at conferences, or maybe to present to defend my solution, in front of customer and so on and so forth. So different things can be improved, or new skills can be gained here. We have also so-called technology excellence initiative, where we have kind of quite broad community. So basically it's global across EPAM, where we have lots of different engineers, architects, delivery managers, and so on, which are sharing their experience. And there are roundtables with discussions of recent technology trends, architectural styles, patterns, and so on and so forth. Global Solution Architecture team, this is kind of relatively close group of architects which are responsible to develop architecture discipline within EPAM. So some templates, practices, best practices, and so on are developed within this group. And we have kind of onboarding course for the newcomers from architecture perspective to understand what can be found and where. Yeah, that's basically it from my side. Thank you for your attention. And if there are questions, I will be happy to answer them. If you want, you can unmute yourself, or you can write to the chat.
First of all, I want to thank you. And one more small question. I've heard that we have different kind of architects, solution architects, application architects. So today we was talking about solution architects, right?
Mostly, yes.
Mm-hmm.
Any other questions?
Should the architect write code, or is just like level of diagrams and etc.?
Yeah, good question. Might be controversial one, but there are different opinions on that, right? But from my perspective, architects should code, right? And in our organization, there is like encouragement to be hands-on at any level, right? We have like CTOs who are still coding. For sure, like they do not code as like they do not implement stories on the projects and so on, right? But they still hands-on. Talking about my personal experience, like again, like I cannot implement end-to-end some user stories, right? Talking about like agile development or Scrum, but I can contribute to the project with some POC, or maybe if it's a pre-sale and we need to write some POC, I'm happy to code. This is actually quite good. And like we usually architects are developers in the past, and most of them like to code. That's why it's encouraged to be hands-on, to still be hands-on and to code. So the short answer, yes, architects should code. Any other questions? Okay, so if there are no questions, I think we can wrap up. Thanks for joining us. Hope to see you once again in our upcoming Tech Talks. Have a good evening, day. It depends on where you are. Okay.